Assalamualaikum and hi to everyone who's watching this video. My name is Hartini Binti Zamzan and my metric number is AN190107. My supervisor is Professor Media Technologies Dr. Nurhanis Hayati Binti Hairom from ZTKK FTK. In this video, I will present my final year project 1 with the title Different Ratio Formulation of ZnO-MO Nanofluids for Industrial Dye Wastewater Treatment via Membrane Photocatalytic Reactor (MPR). In this presentation, I will include introduction, literature review, methodology, expected result, conclusion, and also Gantt chart. Ladies and gentlemen, when Malaysia implemented export-oriented industrialization, textile industry were prioritized alongside a few other countries. Consequently, the industry has experienced consistent growth over the years. 10,000 tons of dyes are being utilized in the textile industries. Zinc oxide's photocatalytic potential has been intensively investigated due to its favorable properties, which include a high excitation binding energy, large surface area, high degree of reactivity, non-toxicity, and chemical stability. Green synthesis is an evolving area in which harmless chemicals are produced using eco-friendly and biosafe reagents. It is also a feasible alternative to physical and chemical processes. Green synthesis techniques use plant phytochemicals such as polysaccharides, proteins, amino acids, alkaloids, flavonoids, and terpenoids as stabilizing agents to zeologically convert metal oxides or metal ions to metal nanoparticles in an aqueous solution. Mangifera Odorata, or often known as quinine or quinine in Malaysia. Antioxidant activity in mangoes and wild Mangifera species, including Mangifera Odorata, was discussed by Adnan et al. Next, determining the optimal conditions of the photocatalytic degradation process in the presence of ZnO-MO nanofluids in MPR is thus another objective of this work. This research is regarded to have a significant capacity to conserve environment for present and future generations. Ladies and gentlemen, for your information, the textile industry's untreated effluents contain a wide variety of organic contaminants, with textile dyes being the most abundant. Green synthesis of ZnO nanofluids using plant extract is still inadequate. The employment of a green capping agent for the synthesis of ZnO nanofluids can help decrease the limitations of ZnO-PVP and ZnO-PEG, which produce hazardous byproducts. To date, no studies have been conducted on industrial dye wastewater treatment via MPR in the presence of ZnO-MO nanofluids. The objectives of this study, first, is to formulate the different ratios of ZnO nanofluids to leaf extracts of Mangifera Odorata, MO. Second, to assess the performance of ZnO nanofluids for industrial dye wastewater treatment in MPR. Thirdly, to analyze the membrane flux decline and membrane fouling in MPR. The scope of study for this proposed project firstly is the synthesis of ZnO-MO nanofluids by different loading of MO, which is 0.02 ml, 0.12 ml, and 0.0067 ml that produce three different ratios of ZnO-MO, which are 3:1, 5:1, and 9:1. Secondly, the characterization of ZnO-MO nanofluids by using X-ray diffraction (XRD) and transmission electron microscopy (TM). Thirdly, the assessment of the performance efficiency of photocatalysts, which, in absence of ZnO, commercial ZnO, and ZnO-MO nanofluid for industrial dye wastewater treatment in MPR. Fourthly, the analysis of treated wastewater quality in terms of color intensity, turbidity, COD, and BOD. And lastly, the analysis of membrane flux decline and membrane fouling after filtration process in MPR. Zinc oxide nanoparticles is a white, solid, and odorless. Because of its nano size, zinc oxide nanoparticles are able to remove unwanted substances since they have high absorptive performance as compared to conventional absorbents. Zinc oxide also has a high excitation binding energy, a wide surface area, a high degree of reactivity, non-toxicity, photosensitivity, and chemical stability. Its photocatalytic potential has been the subject of many research. Nanofluids consist of nanoparticles suspended in a liquid solvent. Metals, oxides, carbates, and carbon nanotubes are typical nanoparticles created using nanofluids. These nanofluids possess a significant level of antibacterial activity against a broad range of microorganisms, including gram-negative, gram-positive, respectively. Thus, establish their high potential for use in purification or disinfection of highly polluted water. The three phases of ZnO are cubic rock salt, cubic zinc blend, and hexagonal wurtzite. DES in analytical extractions has attracted significant attention, mainly due to its structural versatility and wide range of applications. Those solvents have favorable psychochemical properties and are typically composed of mixture with lower melting points than their constituent components. DES are binary or ternary mixtures produced by hydrogen bonding to form eutectic mixtures. Components may contain a hydrogen bond acceptor, HBA, and a hydrogen bond donor, like as shown in the slide. DES exhibit a high degree of versatility with multiple possible combinations of greener alternatives to conventional organic solvents. HBA and HBD, such as quinine for this research. Mixture of these components at molar ratio of 1:1 or 1:2 produce liquids at room temperature that are thermally stable, volatile, and viscous. DES is an eco-friendly solvent that possesses several desirable characteristics and chemical tunability and a direct preparation. These characteristics make DES a viable alternative to organic solvents with high toxicity level. Farouk et al. And Hansen et al. Have demonstrated the potential of the solvent in various fields or applications. Next, green synthesis is based on the well-documented ability of any organism to reduce metal ions without stabilizing them into nanoparticles. Compared to microorganisms, plants are considered the best candidates for green synthesis of nanoparticles because they produce large quantities of stable, variable-sized nanoparticles for large-scale applications. Plant parts have been used extensively in the synthesis of zinc oxide nanoparticles such as leaves, stems, bark, roots, rhizomes, fruits, flower, and seed because they are stable, highly pure, and cost-effective. Plants possess a rich diversity of secondary metabolites that merit investigations. Scientists recently were interested in phytoconstituents produced by plants to investigate their bioreduction process of metal nanoparticles by secondary metabolites. For photocatalytic degradation process, when semiconductor catalysts consume energy which is photons higher than their band gap energy, charge separation occurs due to an electron jumping from the valence band to the conduction band, creating a hole in the valence band. When illuminated by light with a higher energy than the band gap, electron-hole pairs are generated and diffused to the photocatalyst surface where they participate in a chemical reaction with electron donor and acceptor. Certain free electrons and holes convert the surrounding oxygen or water molecules into highly reactive, unstable hydroxyl radical, which is a free radicals during intense oxidation. When zinc oxide nanoparticles absorb photons with energy exceeding their band gap energy, photocatalytic reactions begin to degrade dyes. Membrane photocatalytic reactor or MPR is a hybrid system that combines photocatalysis and membrane filtration to generate high-quality permeate, high photocatalytic efficiency, convenient to adjust photocatalyst concentration to avoid membrane damage, and promising practical application in bigger scale. MPR also uses membrane filtration to separate pollutants in water and permits the rejected pollutants to be degraded via photocatalysis. Pressure-driven membranes for MPRs in which the photocatalysts are combined with pressure-driven membrane-based processes such as microfiltration, ultrafiltration, or nanofiltration. Next, the methodology for this project. The flow for this study started by synthesizing ZnO-MO, and ZnO-MO will be characterized by using XRD and FTIR. Then, wastewater treatment will be conducted in MPR system with absence of ZnO, commercial ZnO, and different ratios of ZnO-MO nanofluids. Then, the quality of permeate and analysis of membrane flux decline will be checked if it's complied to the EQA 1974 standard or not. Lastly, analysis and data will be collected. The materials and chemicals will be used in the study is as shown in the video. The sample of industrial textile wastewater will be collected from the effluent tank from a textile factory located in Johor. Next, the synthesis of ZnO-MO nanofluids will be started with the mixture of chlorine chloride and urea will be heated in an airtight flask by setting the temperature of the hot plate to 80 degrees with the constant stirring at 120 rpm with a magnetic stirrer in the beaker until a homogeneous colorless mixture will be formed, which is DES. Then, the DES solution will be cooled until it reaches room temperature. Then, zinc acetate and sodium hydroxide NaO will be dissolved in 60 ml of DES solution. Then, the different ratios will be formulated by different loading of MO, which is 0.02 ml, 0.12 ml, and 0.0067 ml, that will be added into the mixture in 3 conical flasks. Next, the conical flask will be wrapped fully by aluminium foil and will be stirred for 24 hours at 250 rpm using an orbital shaker. The SRD will be used to characterize crystalline materials, and TEM will be used to visualize specimen and generate highly magnified image. Then, the permeate will be analyzed using analytical method to check its color, turbidity, COD and BOD. The expected results for this study has been clarified as follows to the objective of this project. The expected best ratio of ZnO-MO nanofluids to treat industrial dye wastewater via MPR is 9 to the ratio of 1 with a MO capping agent loading of 0.0067 ml. The water quality of treated industrial dye wastewater is expected to conform to the Environmental Quality Act of 1974. So, for the conclusion, this study is expected to follow the main objectives, which to investigate the ZnO-MO nanofluids performance via MPR under different ratios. As I explained, it can be concluded that ZnO-MO nanofluids can be a good photocatalyst and increase the photocatalytic efficiency. However, ZnO-MO nanofluids research is still limited in treatment of wastewater. So, this research is regarded to have a significant capacity to conserve the environment for present and future generations. Here is the Gantt chart for the purpose project. Yellow indicates the planning progress, and purple indicates the actual progress of this project. Thank you for watching my video and have a nice day.